Right now, you are breathing, not thinking about it, not trying, just doing it. Your lungs expand, pull in a mixture of gases, and your blood does something extraordinary with the oxygen. It carries it, molecule by molecule, to every cell in your body, and each of those cells burns it quietly to keep you alive. You are doing this every 4 seconds. You have done it roughly 500 million times in your life, and you have never once had to remember. That alone is worth sitting with for a moment. But here is the part nobody tells you. The oxygen you just inhaled, those molecules, were not made on Earth. They were forged inside a star that died before our sun was even born. A star so massive it ran out of hydrogen, then helium, then burned through carbon, neon, oxygen, silicon, each stage faster than the last, until its core collapsed in a fraction of a second, and it exploded with more energy than our sun will release across its entire 10 billion year life. That explosion scattered those atoms across space. They drifted. For hundreds of millions of years, they drifted. Eventually, gravity pulled them into a new cloud of gas and dust. That cloud collapsed into our solar system. The atoms settled. Some of them became rock, some became ocean, some became algae, then plants, then the atmosphere you are breathing right now. You just breathed the inside of a dead star. This is not a metaphor, this is chemistry, this is astrophysics. This is the actual story of the oxygen in your blood right now. We talk about the universe as something out there, something vast and cold and indifferent, something you look at through a telescope on a clear night and feel small in front of. But that framing gets it backwards. You are not looking at the universe from the outside. You are part of it. You are made of it. Every atom in your body has a history that stretches back 13.8 billion years, and that history passes through supernova, through nebulae, through the hearts of stars we will never see. The universe did not create you the way a factory creates a product. It created you the way a river creates a delta, slowly through 1 billion branching decisions, each one building on the last, none of them planned. And now here you are, aware of all of it. That is the thing that should stop you cold. Not the size of the universe, not the number of galaxies. Those numbers are so large they stop meaning anything after a while. 200 billion galaxies, 2 trillion if you count the ones too faint to see, each with hundreds of billions of stars. You can read those numbers and feel nothing, the way you can read the word billion and not actually picture a billion of anything. What should stop you is this. The universe existed for 9 billion years before anything in it could ask a question. For 9 billion years, there were stars, there were explosions beyond description, there were collisions between galaxies spanning hundreds of thousands of light years. There was violent, extreme, almost incomprehensible activity happening everywhere, all at once, for 9 billion years. And none of it knew it was happening. Then, about 3.8 billion years ago, in a warm, shallow sea on a small rocky planet orbiting an unremarkable star, something happened. A molecule copied itself, just that. A molecule copied itself imperfectly, and those imperfect copies competed, and over unimaginable stretches of time that competition produced cells, then multicellular life, then nervous systems, then brains, then, eventually, a species that could look up at the sky and wonder what was out there. The universe became aware of itself, and it did it through us. This is not a comfortable thought. It comes with weight. Because if we are the mechanism through which the universe looks at itself, if consciousness is genuinely rare or genuinely new or genuinely fragile, then what we do with that awareness matters in a way that is hard to put into words. But before we get there, before we get to what it means, we need to understand just how large the stage is. Because once you actually feel the scale of this thing, not just read the numbers but feel them, the question changes, the weight of it changes. Start with something you can hold, a human cell. About 10 micrometers across, roughly 1/10 the width of a human hair. Inside it, a nucleus, mitochondria, a membrane, thousands of proteins doing specific jobs. It is, by any honest measure, more complex than anything humanity has ever built. and your body contains roughly 37 trillion of them. Now pull back. Your body is about 1.7 meters tall, give or take. It is warm, it is temporary. It contains roughly 7 octillion atoms. That's a 7 followed by 27 zeros. And here is the first number you need to feel rather than just read. If you took every atom in your body and lined them up end to end, that line would reach from Earth to the Sun and back, not once, about 1,000,000 times. You are made of almost nothing. The atoms in your body are mostly empty space. The nucleus of each atom is so tiny compared to the space around it that if you scaled an atom up to the size of a football stadium, the nucleus would be a grain of sand at the center. What feels solid, your hand on your knee, your feet on the floor, is almost entirely void, held together by electromagnetic forces so precisely balanced that the matter never actually touches. You are not touching anything. You never have been. Keep pulling back. Earth, 12,742 kilometers wide. It looks enormous when you stand on it. From the moon, the only other world a human has ever stood on, it is a marble. A blue marble, which is a phrase people use so often it has lost its shock. So try this instead. The moon is 384,000 kilometers away. Light, the fastest thing in the universe, covers that distance in just over 1 second. You could say the moon is 1 light second away. The sun is 8 light minutes away. When you look at the sun, or look away from it because you know better, you are seeing it as it was 8 minutes ago. That 8-minute-old light is what gives you vitamin D, what drives the weather, what makes the plants grow. The present tense, as far as the sun is concerned, is already the past by the time it reaches you. Real science anchor. The speed of light is 299,792 kilometers per second. Light takes 8 minutes, 20 seconds to travel from the sun to Earth, confirmed by solar distance measurements via radar. Now pull back further, past Mars, past Jupiter, past the outer planets, past the edge of the heliosphere, the bubble of solar wind that marks where our sun's influence ends and interstellar space begins. Voyager 1, launched in 1977, has been traveling for nearly 50 years and only recently crossed that boundary. It is the most distant human-made object in existence, and it is still inside our solar neighborhood. The nearest star, Proxima Centauri, is 4.2 light-years away, not 4.2 light-minutes, light-years. At the speed Voyager 1 is currently traveling, about 61,000 kilometers per hour, which is fast enough to circle Earth in under 26 minutes, it would take approximately 73,000 years to reach Proxima Centauri. Well, we sent something into space in 1977, it has never stopped moving, and it would take 73,000 years to reach the next star. The emptiness between stars is not space, it is a kind of silence that has no comparison on Earth. Now the galaxy. The Milky Way is roughly 100,000 light-years across. It contains somewhere between 100 and 400 billion stars. Our sun sits about 26,000 light-years from the center, in a quiet suburban arm called the Orion Spur. The galaxy rotates. Our sun completes one orbit of the galactic center every 225 million years. The last time our sun was in this same position relative to the galaxy, dinosaurs had not yet appeared on Earth. And the Milky Way is not special. It is not the biggest galaxy, not the smallest, not the most active. It is one of roughly 2 trillion galaxies in the observable universe. 2 trillion. Each one containing hundreds of billions of stars, many of those stars with their own planets. Real science anchor. The 2 trillion galaxy estimate comes from a 2016 study published in Science by Consolis et al., using the Hubble Deep Field images combined with mathematical modeling of galaxy density across cosmic time. Here is the gut punch. The observable universe, the sphere of space from which light has had time to reach us in 13.8 billion years, is 93 billion light-years across. But the full universe may be vastly larger than that. We cannot see it. We cannot measure it. We can only know that there is almost certainly universe beyond the horizon of our observation, and that horizon is not the edge of anything. It is only the edge of what we can see. The universe does not end there. It simply continues beyond our reach, in all directions, possibly forever. Possibly forever. And across all of it, the 93 billion light-years we can observe, plus whatever lies beyond, the distribution of matter is almost perfectly smooth. On the largest scales, the universe is homogeneous. The same ingredients, the same physics, the same laws, everywhere we have ever looked. Which means the conditions that produced us, that produced life, consciousness, the ability to ask where we came from, those conditions were not localized to Earth. They are written into the physics of the universe itself. So here is the question that should be keeping you up at night. If the same physics that made us exists everywhere, if the same atoms that built our bodies are scattered across 2 trillion galaxies, or if the same stars that burn to make our oxygen are burning in every direction you could possibly point a telescope, are we the only place this happened? Are we the only matter that became aware of the matter around it? Is this, all of this, a universe that woke up in exactly one place, briefly, and will go dark again without ever knowing if it was alone? Here is what we know for certain. For 9 billion years after the Big Bang, the universe existed with no observer. Stars were born and died. Black holes devoured entire solar systems. Galaxies collided in slow-motion catastrophes lasting hundreds of millions of years. All of it happened in perfect, total, absolute silence. Not the silence of a quiet room, but the silence of something with no one inside it to hear. Then life appeared. And for most of life's history on Earth, for over 3 billion years, it was microbial, single-celled, reacting to the world but not reflecting on it, surviving but not witnessing. Somewhere between 300,000 and 100,000 years ago, depending on how you define it, and the debate is genuinely unresolved, anatomically modern humans appeared. And with them came something the universe had never contained before, a perspective, a point of view, a creature that could stand in the dark and look up and ask what it was looking at. That is not a small thing. The physicist and cosmologist Carl Sagan said that we are a way for the cosmos to know itself. And that line has been repeated so many times it has become almost decorative, the kind of thing that gets printed on posters. But strip away the familiarity of it and look at what it actually claims. The universe, 13.8 billion years old, 93 billion light-years across, containing more stars than grains of sand on every beach and desert on Earth, has found a way to examine itself. Through chemistry, through evolution, through the slow and brutal process of life learning to survive well enough, long enough, to eventually look back at where it came from. We are not in the universe. We are the part of the universe that got complicated enough to notice the rest of it. This changes the question of meaning, not in a religious sense, not with any claim about purpose or design, just as a plain observation about what is happening here. Meaning in the philosophical sense usually requires a subject, something that experiences, something that cares. The universe, on its own, does not care. It follows its laws. Gravity pulls, light travels, stars burn and die. None of it cares, but we care, and we are part of it. So when we say the universe is indifferent, we are only half right. The universe is mostly indifferent. But there is this one corner, this one thin layer of organized matter on the surface of a small planet, where the universe has become, briefly, not indifferent at all, where it feels things, loses things, wonders where it is going. The physicist Brian Cox has pointed out that the atoms in your left hand likely have a different history from the atoms in your right. They pass through different stars, different nebulae, different corners of the galaxy before ending up here in you, assembled into something that can think about where they came from. Your body is not a thing in the universe. It is the universe, assembled locally, temporarily, into a shape that can reflect. Temporarily is the key word. In around 5 billion years, the sun will exhaust its hydrogen fuel and expand into a red giant, most likely consuming Earth entirely. Long before that, the sun's increasing luminosity will make Earth's surface uninhabitable. Within roughly 1 billion years, it will be too hot for the oceans to remain. On an even shorter timescale, the civilization we have built, the science, the art, the accumulated knowledge of what we have learned about the universe we live in is fragile in ways we have not yet fully accepted. This awareness is borrowed time. It always was. And that is not a reason for despair. It is a reason for attention. Hey, because the extraordinary thing, the thing that should strike you every time you look at the night sky, is not how vast the universe is. It is not how small we are. We have been told those things so many times they have stopped landing. The extraordinary thing is that we got to know any of this at all. That the universe, through some improbable chain of events spanning billions of years, produced something capable of understanding supernovae, measuring the distance to galaxies and sitting quietly in the dark and feeling the weight of its own existence. That has never happened before. As far as we know, it has only happened here. Somewhere, right now, a star is dying, burning through its last reserves of fuel, collapsing, exploding, scattering its atoms into the dark between galaxies, and it has no idea. It is magnificent and violent, and it will never know it happened. But you sitting here, made of atoms just like those, on a rock orbiting a star just like that, you know. And for whatever small window of time that knowing is possible in this universe, the question worth living inside is not what are we made of, but what do we do with the fact that we can ask?